Good morning. This is Professor David J. De Los Reyes. My topic this morning will be a differential equation subject matter, variable, separable, and this will be on the leaking water tank. Okay, let's proceed, guys. My new lesson on my channel, okay? It will be on the topic differential equation, subtopic variable separable, and on the application problem, it will be the leaking container. This will now be an application of a variable separable differential equation, that is on the computation of the volume remaining on a leaking container. The relevance of this is something like if Elon Musk tried to fly an SpaceX shuttle, how long will be the fuel of that shuttle be diminished after so many hours? So it is just similar to the so-called leaking water tank. Okay. I don't know why scientists used to fly SpaceX shuttle going up, right? So if they don't know how to compute how much will be the fuel remaining at any given moment in time, there's a problem. So it's a must that scientists should know how much will be the remaining fuel at any moment in time. And this is similar to this problem here. Okay. I will try to read the problem. I didn't write it, it was quite a little long. So we minimize space. Okay, I will try to read the problem. Water leaks from a cylinder with access vertical through a small orifice in the vase at a rate proportional to the square root of the volume remaining at any time. If the cylinder contains 24 gallons initially and 15 gallons leak out the first day, when will 25 gallons remain? And the next question is, how much will remain at the end of 4 days? How much will remain at the end of 4 days? So the problem is something like this. If we try to figure out, we got a cylindrical container, okay? It says the axis is vertical, okay? Initially, the tank is actually with 64 gallons inside. And there is an orifice at the bottom. And the rate of leak is proportional to the square root of the volume remaining at any given moment in time. That is given on the problem. The rate of leak is actually proportional to the square root of the volume. Okay? So if we try to bring out the initial conditions, initially the contents of the water tank is 64 gallons. This is gallons. Okay. After 24 hours, 15 gallons leak out. Okay, so what remains inside the gallon will be 64 minus 15. So after 24 hours, what remains inside is 49 gallons. This is 49 gallons. Okay, we got the first question. When the volume inside the tank is 25 gallons, what will be the elapsed time? After how many hours will pass out till the volume inside the water tank is 25 gallons? And the next question is, after 96 hours, how much is the volume remaining inside the tank? So actually we got two unknowns over here. So if you try to figure out the problem, this should be the tank. It is erected perpendicular to the axis is actually with respect to the y-axis. This should be the y-axis. So it is erected vertically. So this should be the little ground. These are the base of the tank. And there is an orifice at the bottom. Water is leaking out on the orifice at the bottom of the water tank. So the question is, after when the volume inside is 25 gallons, how much time will pass by? And after 96 hours, how much is the volume remaining inside the tank? Is there still water inside the tank after 96 hours? Okay, let's try to bring out the solution. This falls under differential equation, variable separable, leaking container. Okay, let's try to bring out the solution. The given condition is that the rate of leak is actually proportional to the square root of the volume. Okay, so if we try to bring out an equality sign over here, dB over dt equal to a certain constant k, the square root of b, square root of the volume. Okay, we try to separate the variables. We put this square root underneath, and we put this dt here on the right. So what will come out will be dB over the square root of volume equal to k dt. So after the algebraic manipulation, we already have separated the variables. This is pure function of b. The right hand side is just simply k and differential time. So it seems you are now given volume as a function of time. Differential volume. So actually we could now integrate both sides. Pure dB, this is just dt, so we could proceed with the integration. Right? Proceeding with the integration. The integral of dV over the square root of b equal to the integral of k dt. We are now integrating. Right? The left hand side can be written as, if we try to bring this up, okay, this will become b raised to negative 1/2 dB equal to the integral of the right hand side. We can now proceed with the integration. It will just be simply k times t, because the integral of dt is just t plus an unknown constant of integration k sub 1. Okay, let's try to integrate the left hand side. This should fall under the power formula. The value of u inside is actually v, du is dv, it is exact. Okay, so we could use the power formula. The integral of u to the n dv is u to the n plus 1 over n plus 1. So this should be b raised to minus 1/2 plus 1. Okay, minus 1/2 plus 1 is actually plus 1/2 all over 1/2 equal to kt plus k1. Okay, this will become 2 the square root of b equal to kt plus k1. So this is now the general solution of the differential equation. General solution, why? We do not know the value of k for the meantime. We do not know the value of k1 for the meantime. It is referred to as general solution. Okay, let's try to compute for the constant of integrations. We are given two conditions. At time t equal to 0, the volume is 64. Okay? And at time t equal to 24 hours, the volume is 49. So actually, we could use these initial conditions to compute for k and k1. Okay, let's use the first one. At time t equal to 0, the volume is 64 gallons. Therefore, this should be 2 the square root of 64 equal to k times 0 plus k1. But this is 0. There is only one unknown, right? So we can compute for k1 now. 2 the square root of 64 will be 2 times 8. That will be k1 will be equal to 16. Okay? So the partial general solution is this one. Partial general solution. Why partial? For the meantime, we do not know the value of k. Okay, let's try to compute for the value of k. At time t equal to 24 hours, volume is 49. So we go back here, we substitute values. This should be 2 the square root of 49 equal to k. I'm following this, times 24 plus 16. If you try to simplify this one, it will be negative, the value of k is negative 112. Why 112? 2 times 7 will be 14. Okay? 14 minus 16 will be minus 2. Right? Equal to 24 times k. So k now will be equal to negative 2 over 24. Or k is equal to negative 112. This is negative 112. So the resulting particular solution now will be 2 the square root of b equal to, I am following this and substituting the values of k and k1, this should be negative 112 times time plus 16. So actually we are now given volume as a function of time. And we derive this relation here using our knowledge of differential equation under variable separable. Okay, let's try to answer the first question. When the volume is 25, how much will be the time that will pass by? I'll just use this equation here. Substitute the volume given and we could compute for time. So this should be 2 the square root of 25 equal to negative 112 times t plus 16. What will come out for time will be 72 hours. It is 72 hours. You could compute this one, guys. It will be 2 times 5 is 10, right? We transpose the 16 here. So 10 minus 16 will be negative 6, okay? Negative 6 times negative 112 will be, this should be 72 hours. So the meaning of that, when the volume inside the tank is 25 gallons, the time that will pass by will be 72 hours or 3 days. So if your water tank is leaking, you are lucky. There is still a volume of water left inside. If you do not know that it was leaking, you know. Okay, let's compute for the next requirement. After 96 hours or 4 days, how much will be the volume remaining inside the tank? Or just go back to the derived particular solution. So this should be 2 the square root of b equal to negative 112 times 96 plus 16. 96 over 12 is actually 8, right? So minus 8 plus 16 is plus 8. 8 divided by 2 will be 4. Therefore, square root of 4 equal, or square root of volume, unknown volume will be 4. Then try to square both sides. The square root of this, the square root of volume will just be simply volume. And the square of the right hand side will be 4 square, and that will be 16. See? 16. So the unknown volume after 96 hours is actually 16 gallons. We are still lucky. After 4 days, we still got a volume of water that remains inside the tank. And the amount of water remaining is actually 16 gallons. Okay, guys? Oh, that's an application of a differential equation under the topic variable separable. So actually, you could relate this one to the fuel of a space shuttle going into space. So actually, scientists know when the fuel for that shuttle will be diminished, you know. So actually, they could design that one that it could go up, then it could go down. Because if it will go up, then the fuel is consumed. That's it. They are not good. So it's a must that it can go up, then it can go down by using the fuel inside the container tank of that space shuttle. Oh, good afternoon, Los Angeles. Oh, good morning, Los Angeles.